Hi, question number 2. What type of function fits each situation? So I have two functions here in two different tables. I have h of x and g of x. And we've got some helpful hints over here. So I'm going to read through the helpful hints before we analyze my tables. Um, we have two different types of functions we're trying to choose between here. We have a linear function and an exponential function. So a linear function, as the input increases by 1, the output changes by adding the same number. It has a common difference. So right here you can see these are all increasing by 1 as I move up in my x's, and I want to know if this has a common difference. Am I adding the same number as I move through my table? Okay, that's one option. The other option is it being an exponential function, and that's as the input increases by 1, the output changes by multiplying the same number. It has a common ratio. Okay, so we multiply for the common ratio and we add for the common difference. So to determine if we have a common difference, we take the second term and we subtract it from my first term. So my second term here would be 5, or negative 5, excuse me, and I would subtract that from my first term of negative 7. And negative 5 minus negative 7, that turns into a positive, that would end up giving me 2. And if I were to test that again, if I did it with my third and second terms, if I did negative 3 minus negative 5, oh look, when I add those two together, I end up getting positive 2. So if I continue to test that theory, if I add 2 here, if I add 2 again, I get negative 3. If I take negative 3 and I add 2, I get negative 1. If I add 2 to negative 1, I get 1. So for h of x, I do have a common difference of 2. So it's a linear function. My answer is linear because I'm adding the same value for every term. Now my second function here, g of x, we might just want to go ahead and assume it's exponential because, well, we just did a linear example, but let's just go show you how we would determine it's not linear. So again, we want to look at those input values, and they are being separated by 1. We're increasing by 1 every time. So when I go to look for my common difference, if I start here at my second term and I look back at that first term, 3 minus 1.5 would give me 1.5. Well, if I tried to take that 1.5 and add it to 3, that doesn't give me 6, does it? Because 3 plus 1.5 gives me 4.5, so that's not going to work. That's why I know it's not linear. But to make sure that it's going to be exponential, we can go ahead and test for that. So exponential has a common ratio. We're multiplying by the same value every time, and we take that second term and we divide it by the first term. So 3 divided by 1.5 gives me 2. So essentially what I'm doing is every time I'm multiplying by 2. 1.5 multiplied by 2 gives me 3. 3 multiplied by 2, oh look, that gives me 6. 6 multiplied by 2, that gives me 12. 12 multiplied by 2 gives me 24. So there's a common ratio here of 2, making this an exponential function.